There we go. Okay, so it's recording. So let me write the main statements. So we have this one, probability H is less than 94.6 is equal to 0.288, and then you have probability H more than 98.1, and that's 0.434. So we have two statements, and H is the height. So the height follows a normal. The question it tells you it follows a normal with mean mu, and the standard deviation is sigma. So for a normal distribution, it's mu sigma squared. That's how it's written. Now for part A, it tells you that the probability that the height of a randomly selected plant is between two numbers. So the probability that H is between, sorry, not between, but let me correct that. The probability that H is less than 94.6, that's one statement, that's 0.288. Then the other statement is probability H more than 98.1, that's 0.434. So we have two statements. We need to find mu and sigma.
Oh, I skipped A by accident when I was reading the question.
Ah, okay. We need to
find the probability.
Yeah.
Yeah.
We need to do A to get the mu and sigma.
You find the probability that's between.
Yeah.
Right? And the probability is between is just add the two probabilities minus 1.
But then how would that allow you to find the mu and sigma though?
Oh, I don't know.
Yeah, I mean it's a good idea, but then the aim is to get the mu and sigma. That's find the property. Yeah. It's between. Yeah. You're right. You're right. So property it's less is this, property it's more is this. So part A, it's 1 minus.
So it'll be probability of H, probability of H being greater than 94.6, being less than 94.6, and being greater than 98.1.
Yeah. Yeah. So you're correct. To do the first part, we just do 1 minus because total probability should be 1. Okay, so on the graph
is equal to 1 minus 0.288 plus 0.434. 0.278. So now we have all the probability.
Yeah, so it looks like that. They've given us the tails. They also to find the middle, so it's just total probability 1 minus these two. Yeah, okay. That will be part A. That's why it's 2 marks.
Then do we half this probability to find the probability for the exact mu?
No.
Or do we not do that because we don't know that the mu is actually in the middle of these two?
Yeah. So let me show you how we would work out the second part. So the first part is just this. For the second part, we need to actually take each statement and apply something called standardization. That's what I was referring to. So let me show you how it's done. So we have this statement, okay? When we standardize, the variable becomes Z. And the process is like this.
Oh, I remember seeing this.
Yeah, you subtract the mean, you divide by the standard deviation.
Yeah, I think I have notes on this in another book, but it's like longer.
So this is what we get, and then to actually get that number, which represents the 94.6 minus mu over sigma, that's where you do inverse normal. Okay, so depending on your calculator here, we would do an inverse normal. Okay, left tail, because we're working with less than something. So in terms of the graph,
I don't think. Wait. Oh yeah, left tail. Yeah.
Left tail. So if you do inverse normal left tail with the 0.288.
So the area would be 0.288.
Yeah, exactly. It should give you this.
Do I leave mu as 0?
Yeah, because you've standardized, so the mean is 0. Correct.
So mu is 0, and then
Sigma is 1.
Deviation is 1.
Perfect. Yeah.
And then I got minus 0.559.
Perfect. Yeah, that's what I wrote. So I used the Casio and I got that, but yeah, you got something similar. So that's
wait,
the.
I just want to write this down.
Yeah, write it down. So this value is what this expression is.
So Z. So this would be called standardization. 94.6 minus mu over sigma equals 0.288. Inverse null equals left tail. Left tail is because it has to be less than.
If it was greater, you would have done the right tail.
Is equal to minus 0.5. 559. Do I do as many as I can?
Yeah. So in my workings, I used what's on the board right now. 0.559 2369.
236973. And that's for what?
And that's your first equation. So if you cross multiply, you'll get an equation with mu and sigma in it. Okay.
Oh, and then you do a second one for the other one, and then you do what's it?
Simultaneous equations.
Yeah, simultaneous.
Exactly. That's why they gave you the second piece of info.
Equation 1.
Yeah, that's equation 1.
Then we do P H is greater than 98.1 is equal to 0.434. 0.434, which means P of Z greater than 98.1 minus mu. That is equal to 0.434. We do inverse form.
Right tail, this one. Yeah.
Equals to
19944.
equals 0.16619994.
Perfect. Yeah, I got the
314.
Yeah.
And that's equation 2.
Perfect. And now you solve these two simultaneously.
And now there's two unknowns.
Yeah. Simultaneous equations, two equations, two unknowns.
Stick that into my calculator. Simultaneous equation solver, two equations, two unknowns.
Yeah.
I have to make mu and thingy something to formula though to make it easy to plot in.
Yeah.
Okay.
Can you confirm what you got?
Yeah, I just need to put it in real quick.
All right.
So then, if I pull it by itself, that would be 94.6 minus mu is equal to minus 0.55 blah 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 sigma. Okay, so you just multiply sigma to the other side, and then you can just make it so it's a formula.
Yeah.
Okay, that's. Okay, so I do x, I could put mu, so it's 1. Let's do minus 0.559236,973, and this is equal to 94.6, 98.1, 0.1661994,314, and this is 1. I got mu as 97.29814059.
Yeah.
And I got standard deviation as 4.8246822052.
Exactly. I've written these two in the box here. Yeah. So I've written them to 3SF, but yeah, exactly what you got.
Okay, then I do
So that's what they asked you to find. So that's the end of the question.
mu is equal to 97.29 is equal to 4.824. Okay.
Okay.
And that's B done.
That's B done. So I've just rewritten the two equations which you used to get these two answers. Yeah, perfect.
Okay, now it's 100 randomly selected plants. So it's binomial, no?
Looks like it. Every time they give you a fixed value of n, there is binomial involved. So you've got 100 plants, and you need any plant.
If it's randomly selected, that's CDF, right?
It will depend on the question. So
wait, no. CDF is greater than or equal to, and then PDF is exact.
PDF is exact when you're working out x equal to something. Yeah, that's correct.
Yeah, any plant with a height greater than 98.1 is considered ready to harvest. Heights of plants are independent of each other. C1. Find the probability that exactly 34 plants are ready for harvest. So 34, the probability of 34 out of 100 being greater than 98.1.
Yeah.
So you use CDF.
The first part is actually finding the probability that the height is more than 98.1 because we don't know what the probability is. So
right, so you have to find the probability, and the probability would be CDF because it's greater than.
Exactly, normal CDF.
And then you multiply that by 34.
No, that will become the probability of the binomial. So the first thing I would do would be to find the probability. So I would run normal CDF with the lower bound, the upper bound, the mean, and the standard deviation. So depending on your calculator, it takes the values in different ways. That will give me a probability of 0.434. Is that okay, that part? Here I'm finding the probability that the height is more than 98.1. Because the question is about this. Any plant with a height greater than 98.1 is considered ready to harvest. So I try to find that probability first. Is this okay?
Hello?
Yeah, you can hear me?
Yeah, the meeting cut because of the 1 hour period.
Yeah, sure. Let me share my screen again.
Yeah.
So we shared the entire screen last time. Okay.
Right.
Yeah. Open the board. You can see, right?
Yeah.
Good, perfect. So I was saying that we found the property that the height is more than 98.1 first. Okay, because the question is about that. Because the plant is ready for harvest if the property is more than 98 point, if the height is more than 98.1.
Why is it normal CDF? Why is it not binom CDF?
Because the context is still the question. It's about the farmer planting and the height follows a normal. So we're trying to find the property that a plant is more than 98.1.
Well, so is it if the question at
No, it's not the
start
answer yet. That's just part one. Because you know what will happen now. Now it tells.
I understand that, but I'm just trying to distinguish how do you know whether to put binom CDF or normal CDF?
Because we're still using the normal distribution because look at that. Height of plants follows a normal. Okay, with the mean we found, which was 97.3. Yeah. So the height of plants
so if the question starts with each plant can be modeled by normal distribution, that means that normal distribution is for the whole question.
Yeah.
Okay.
Yeah. So we're still working with the height, and the height is a normal. So we need to find the property that the height is more than 98.1, so we need to use this.
Okay, C. So you have to find the probability of the height, so P of H, I mean, it's already given to us of 98.1.
Yeah.
Which is equal to 0.434. But that's also equal to normal CDF, where the height is 98.1. Well, let me see my normal CDF on my calculator.
Yeah.
So the lower the upper bound, so the lower bound would be 97.3, no.
98.1.
The lower bound would be, oh yeah, because it's greater than.
Exactly, so we start there.
And the upper bound is infinite, so e to the power 99.
Yeah.
Then mu is 97.3. And then sigma is 48.2. Lower bound, upper bound. Okay, got that, yeah.
Perfect. So that's the probability, right? Now, in the question, it tells you that the farmer measures 100 randomly selected plants. So n is 100. So I'll write that down. And any plant which with a height greater than 98.1 is considered ready to harvest. So that's why we found it. So the probability that the plant is considered ready for harvesting is 0.434. Okay, so now we have N and P. So now, you see, now it becomes the binomial. And if I have to define the random variable x, I would say...
it becomes binomial once there are trials.
Exactly. Once you have n independent trials and a fixed probability of success, which is this one.
So n is equal to 100. Therefore, use binom.
Yeah.
Is it? Yeah, use binom.
Exactly.
Because of the trials. And p is equal to 0.434. So then I would go to this, and it says any exactly 34. So you would do PDF.
Yeah. Exactly, PDF.
So 100. 0.434, x value 34, 0.0154.
0.01. On 54, you said on the Casio it gave 3.
Oh, wait. I think it's because, no, it's because I didn't put my thing properly. I rounded off for it.
Okay.
If I go into this again, binom PD. Yeah, I forgot to put the 4 at the end of the 4.
Okay.
That means that now it's good for that. Wait, let me just do it again. 100, 0.434, 34, 0.133.
Yeah, perfect.
Use binom PDF. 100 is n, 0.44, p, 34 is x value is equal to 0.133. D.
Okay.
Yeah.
So B is done. Now part C. So for part C,
Given that fewer than 49 plants are ready to harvest, find the probability that exactly 34 plants are ready to harvest.
yeah.
So conditional probability.
Exactly. That's what I was going to write. So every time they say given that, you know it's a conditional probability. But
so the given.
Yeah, how do we write that statement?
Is, conditional probability is P probability of A given B over probability of B.
Yeah, so A given B is written like that, A slash B. That's A intersection B over PB. So that's the theory behind conditional probability. So that's A given B or A conditional B. So here, if I read it correctly, it's given that you have fewer than 49 plants. So
fewer than 49 is probability B.
That's the B exactly. That's why I'm writing it in the second slot. Find the probability that you have exactly 34. So x equal to 34 will be the A.
So probability of B is P of H less than what did it say? Well, no, not H, sorry.
X.
So PB is equal to P of X less than 40. What did it say again? 49.
49, yeah.
49. And PA is equal to P of X equal to 34.
Yeah. So when you work out the conditional probability, you need to find A intersection B. So A is X equal to 34, and B is it's less than 49. So it's 34, and 34 is less than 49. So A intersection B is just probability X equal to 34.
Ah, I see.
Yeah. And then PB is just PX less than 49. So that goes in the denominator.
A and B is P is X is equal to 34 and X is less than 49. Therefore, X is equal to 34. B because 34 is less than 49. Okay? So then that would just be P of A over P of B.
And x equal to 34 you found.
Yeah, already.
Yeah, already. CI.
133. Over, and then probability less than 49.
For this one, you'll need to run a binomial cumulative one, less than 49. Yeah.
So less than 49 is CDF. Trials 100. Wait, what? Oh no, I have to do inverse.
No, there's no inverse. You run a binomial, a cumulative binomial.
What's the cumulative binomial?
So on your calculator, you should have the option between discrete binomial, which is BPD, and then BCD for binomial, which is cumulative, when you're doing less than something. Do you have that option?
I think it might be called something else.
Yeah, it might be called something else on the Texas. Maybe it asks you for lower bound and upper bound on yours.
What was yours called?
On the Casio, it says BCD, which means binomial cumulative distribution.
And what are the values you put in?
But the Casio only takes values less equal to something, less equal to a number. So I did a BCD with 48 because less than 49. So it will start as from 48. If your calculator takes a lower bound and an upper bound, then you should write the lower bound as 0 because the binomial starts with 0.
Well, is it some binom CDF or binom PDF?
Binomial CDF, that's what you need to use.
Yeah. But mine is just, binom CDF is just trials, P and X value.
So it's similar to the Casio one. So your trials is still 100.
Yeah.
Your X value will be 48.
Yeah.
And your P would be the property of the binomial, which is 0.434. Run it?
0.434. Let me try.
Yeah.
0.16144.
2.16. No, it should be something bigger because it's cumulative. You sure you did?
Oh no, mine is 1 minus the probability of yours.
Did you do cumulative for more? Does it give you the option of choosing?
No, it doesn't give me the option. I think this is the thing which I had in my class when we did this. I think it always gave me the right hand side.
Yeah.
And so if it's asking for x being greater, it automatically gives it to me. If it gives me for x is equal to less than, then I have to do 1 minus.
Okay, that's a bit strange. The Casio one by default it works out for less. So
yeah, so I got 0.838.
Yeah. Okay. Is it something which only your calculator does?
Yeah, I think it's only my calculator for that situation.
Okay. So you need to remember.
So I'll just do. I need to remember to do so 1 minus binom CDF of 100 0.434 48 because when x is when x is less than 49 1 minus binom CDF when x is greater than 49 binom CDF. So if it was just greater than 49, I would just put.
Yeah.
I would do the same thing, but I'd put 49 instead, right?
Yeah, because yours, for some reason, is just doing greater. I've never seen a calculator doing that. So as long as you remember that, you're fine.
Yeah, I think I just need to. I think maybe if you give me some more questions I can just validate it later on.
Yeah. I can prepare like a workbook just on working out probabilities, cumulative and discrete, and that will help you.
Yeah, sure.
To practice
Okay.
that. We still have a last part. I think we'll be able to finish the last part too. It's quite a long question. It's quite a long question, this one. So and the one we just did was 6 marks. So far we've got 6 plus 5 plus 2.
I'm just going to shrink all of this so that I have enough space.
Yeah. So quite a big question. Yeah, it's 16 marks total. So if you don't like stats, you're going to lose quite a lot of marks here. So you want me to start with the last part?
Hold up. Let me just. I'm just gonna see if I can select it all.
Yeah.
Why is it not selecting everything? How do I select everything?
What are you trying to select?
I'm trying to select this so I can shrink it. I can just do this. Okay.
Okay. So while you were sorting it out, I just wrote the distribution. Okay. So it tells you that the farmer is growing the same variety of wheat but using a different fertilizer. The height of these plants follow a normal distribution with mean 98.6 and standard deviation d. So it's 98.6 and then d squared. Yeah.
Can you change it? This is not working. So that would be bracket there, and that would be a bracket there. Okay, and I have the space for question D. Yeah, sorry, go ahead.
Good. So it tells us that the interquartile range is 4.82. So I've written it down. Interquartile range is the difference between these two.
48.2.
Okay.
4.82. Right?
Yeah. So interquartile range is upper quartile minus lower quartile. and the lower quartile
Yeah.
is the first 25%. The upper quartile is the last 25% on a normal curve. You okay with that, right?
Yep.
Good, perfect. Now this allows us to create equations.
Should I draw that, by the way?
Yeah. I mean, not necessarily, but I like drawing to get an understanding of what's happening. So I would write Q1 here, Q3 here. Now, why do I usually draw? Because look at the statement I'm going to write now. So the probability that F is more than Q3, that's 0.25. Okay, that's one statement. And I'm actually going to standardize it like we did previously.
So you say the probability of what?
Of F, the distribution, the new distribution with the new fertilizer.
Oh yeah, of F being greater than Q3.
It's 0.25 because that's the upper quartile.
Yeah, exactly.
Yeah. And if you standardize it, it's Q3 minus 98.6 divided by D is equal to 0.
But you wouldn't use F then when you standardize it, would you?
Ah, yeah, sorry. So I would write it as Z because
Z.
it's standard now. Good point. Yeah, so that's one statement. And then the other one would be, you can guess, F less than Q1.
So what's the point of doing standardization again?
To make it become a standard normal, then you can use inverse normal with mean, zero, variance 1 on your calculator. Because we know the mean, but we don't know the standard deviation. So we always standardize.
So basically, whenever you want to find standard deviation or the mean or both, you would standardize.
Exactly.
Okay. I think that would be more ingrained if I just do more.
Yeah. So we would get these two different statements, and then it's similar to what we did previously. So this one will be an inverse normal, right tail, because we're doing greater than, and this will give us the.
But how do you know what D? How do you know D is standard? Oh, I see. Okay. Sorry, I'm just trying to. Okay.
Yeah.
3.6. Okay, is equal to 0.25. Yeah, okay, continue. Sorry.
Yeah, so this will give us this. Okay, if you do the inverse normal, you should get 0.674. So you will do an inverse normal right tail with this value, 0.25 as the area on your calculator. That will give me, if I simplify, 0.674 D. And that would be Q3 equal to 0.674 D plus 98.6. That's a statement with Q3. So we found Q3 in terms of D basically. Then.
So that would ask us to find. Oh no, it asks us to find these.
Yeah.
Okay, I see.
Yeah. Then I'll create something.
What you put Q3 and Q1. Oh no, but that wouldn't work.
Yeah. So I'll try to create a similar statement with this one now.
Oh, I see. Wait, is it you find Q3 and then you find Q1 and then you use the interquartile range from above to substitute it.
Exactly. Then we'll be able to find D because Q3 and Q1 we're going to obtain them in terms of D. Then we would replace back here and get the D. You get it?
Yes.
Yeah. So Q1 will be a similar process. So this standardized value is actually inverse normal of 0.25, but a left tail. Yeah. That
Q1 minus 98.6.
Yeah, that should give me minus 0.674. If I simplify, Q1 is.
Yeah, and the probability should be equal.
Yeah.
So Q3 is equal to 0.674 D plus 98.6. And Q1 is equal to the opposite plus 98.6. And now that we have both of these, and
now you subtract them.
Q3 minus Q1 is equal to 4.82. Then we just substitute them both in, and we'll only have D left.
Yeah, exactly.
You have 0.674 D plus 9 plus 98.6 minus 0.674 D plus 98.6 is equal to 4.82. Those multiplied together 0.674 times 2 1.348. D.
You should get 3.58.
Okay. Then the 98.6 is cancelled out. 4.82 divided by this. Would you say you get 3.58? Yeah.
Perfect. So that's the answer, and that's the end of the question.